thing I'll keep it for later as last section, because that is something we can go one by one, because I think for that I will need at least 2 class. I just hope I can finish that in 2 class. Okay, and now we can start with the algorithms today. Okay, so we'll start with the linear model first. Okay, so before we proceed, let me just show you what I've. Okay, so Sneha, this is again for your information. For machine learning, okay, is divided in 2 groups: supervised and unsupervised. Oh, sorry. Now, under supervised, when I say supervised here, whenever in the data we have our response variable based on which we can do the prediction, or which we will be predicting. So when I have my y variable with me, response, we call it, it in different names. Response variable is one thing. Then we call it as our y variable. Okay, we also call it as our target variable, and we also call that as dependent variable. Okay, so whenever we have these things, okay, then we use generally supervised learning technique, because we have something to predict and something based on which we can train a model, and then we can try to do the predictions. In supervised, it's otherwise. There is no response variable. We just have a huge set of variables using which we have to identify patterns and then cluster them. Okay, so starting with the first technique, in supervised, we have 2 different techniques here. Classification. So I'll just write it down like this. 1. Classification technique. Okay, underline. Then we have regression technique. Okay, these are the algorithms. So these are the wide, I would say, broader name categories. Okay, so I'm going to tell you what algorithms do we have. Now here we have clustering. Basically, unsupervised is used mainly for clustering. Okay, now what algorithms do we have here? In classification, we use decision tree. Okay, and decision tree has many variants. So it has shared, cart, okay, quest, and C5.0. Okay, now this is what we have for decision tree, and logistic regression is the next one. Are you aware what is classification problem? I think we had discussed this in the first lecture, during the first lecture. If you have any doubt, I can again reiterate whatever we discussed the other day. Snehan, are you on mute? Okay. So are you? Do you know what is classification problems are?
No, can you repeat, please?
Okay. So classification is basically predicting categorical variables. Okay, so there are 2 major types of variable. One is numeric, one is categorical. So categorical would be a city name, or like Mumbai or Bangalore or Delhi. Okay, so you can predict out of which, based on different features given in the data, which city is that. Okay, so we have certain categories here, which is finite number of categories. Okay, also to give you an example, it could be a yes, yes or no. It could be true, false. Okay, so we have basically finite number of categories to predict, whereas in the other in regression, we have infinite number. For example, we are predicting sales, or we are predicting amount of rain that's going to fall tomorrow. Okay, so this can take on any value. Sales can be, 1 lakh USD, or it can be 1 lakh 20 point something something something, 10 lakh 20, and then some decimal values as well, and then USD. So here, this is predicting these numbers, which can take infinite regression problems, and these are classification problems where we have finite number of items to predict, categories to predict. Okay, so machine learning, supervised learning is basically predicting whenever we have our response variable or target variable in place in the data. Okay, using that predicting or using that label, we train a model. Okay, using these different techniques that I'm going to write down right below classification, this thing category. Okay, and then we're going to make the predictions. So logistic regression is another thing. Okay, that's another technique of classification. We also have one more, which is called SVM, support vector machine, which is again used for classification. It can also be used for regression, so you have to be a bit mindful. Okay, so there are a couple of techniques that can be used for both classification as well as regression problem. Okay, so while we are going through SVM, maybe I can try explaining that how. So we will be generally dealing with SVM classification problem, but while working on that, I'll also let you know how it can be used in regression problems as well. Okay. Now next is neural net. Okay, and then having if you have these neural nets basically, which is like one layer of neural net, your human brains. One you can just visualize that how a human brain performs, with millions of neurons. Similarly, we have different nodes which are connected to each other in neural net algorithm. Okay, and for one single layer of these nodes, okay, you can consider as a net. Okay, just one layer of net is called as neural net. So there is a package in R called nnet. Okay, so it's not, let's not go through that right now, but there is a package called nnet. So that's again for a single layer neural net. Whenever you increase the layer of this neural network even more, okay, more than one, then they are called deep learning algorithms. Okay.
Okay.
Yes. And then we have SVM here, which is support vector machine, as I had explained. Okay, I think there's one more. Let me just add another row here. Just shift this cell down, maybe. Down. We have naive base classifiers. Okay, so this is again is basically used. Naive Bayes classifier is again a person's name. Bayes is a person's name who has actually developed a probabilistic model, basically, so which uses conditional probabilities to differentiate between scenarios or classes. Now this is generally used for text mining. Okay, and that's something I'm not sure if we have that in the course content, but maybe if I get a chance, then I'll just give you a brief about how exactly this algorithm works. How good are you, Snehan, when it comes to some statistical knowledge about probability theories or calculus or linear algebra? Did you ever worked on these things, or do you remember these things from your college time or whatever?
Yeah, from college time I remember some, but not all.
Mm-hmm. Okay, no problem. So I would recommend you to just whenever you get time, just brush up your knowledge about these probability permutations, combinations, and conditional probabilities, when to use multiplicative and additive and stuff. Because whenever you're studying these algorithms, working on this algorithm, these things generally 70-75% of the time you will see probability theories being used to generate build these algorithms. Okay, so it helps really a lot. And then linear algebra, of course, to visualize the data, okay, identifying different dimensions and stuff. So for that, linear algebra is very important, identifying area under the curve, and then deriving the derivation of a specific part of the curve, or integrating basically again specific part of the curve. Okay.
Okay.
So next one is let's go to the regression. This thing now. In regression, we have a linear regression, which is called okay linear regression. Okay. So this is a normal linear regression, which is what we're gonna work today. Okay. And then we have logistic regression is a part of. I can just find GLM, which is again known as generalized linear model. Okay, linear models. So this is something which is used by insurers a lot, this specific, and even bankers a lot to build any sort of classification model. Again, coming back to the regression thing, so we have linear regression, we have time series. Okay, time series. Have you heard of time series?
Yeah.
Okay, great. Then we have again the same thing, neural net. So similar to SVM, neural net can also be used for regression problems. So these are the algorithms that we have in different categories, classification and regression, that comes under supervised learning technique. Okay, and then we have unsupervised learning techniques where we have k-means. Okay. Oh, there's one more I forgot. So there are many algorithms. Trust me. I mean, it's difficult to sometimes remember whatever you worked on. Let me just shift this thing down a little bit. So that algorithm is very handy when it comes to certain tasks, like this thing KNN. So KNN stands for K nearest neighbor. Okay. So KNN is K nearest neighbor. What it does is using Euclidean distance, between two different points. It tries to calculate, okay, what is the shortest distance from the data point. So this is something that we can, I'm not sure again if it is there in the course content, otherwise I don't think I have the codes ready for this, but that's not a problem. Maybe I can use the codes that I've worked on last time on my last project sometimes before. I can use that and produce another. It's just I have to find a proper data set, a general data set that can be used to take you through that algorithm. So under classification, KNN can also be used, K nearest neighbor. Okay, coming back to clustering, we have k-means algorithm. K-means is again works based similarly like K nearest neighbor. It try to identify the distance between two different points in the 2D plane, and then again it tries to create clusters, using the points that are very much closer. Coming to the next one, which is k-medoid. K-medoid is again, it works exactly like k-means. It's just in k-means it selects one random point, which is an actual point in the 2D space, which you can imagine something like this. Let me just, I don't know how good I'm gonna draw this thing. Okay. Great. Okay, imagine that this is your curve, this is your y-axis, this is your x-axis, and these are some random points on your I don't know how you would type it. It's a bit difficult. Let's assume that you have some points, lying around in different places. Just imagine these are some random points in your data, this thing. Now, based on the distance of these 2 points, okay, the ones that you're seeing here in these 2 cells, it tries to create insert. It tries to create clusters now. So this is my first cluster because these are these number of clusters I can define myself based on my knowledge, and there are different tests to come up with ideal number of clusters that I would require to do the segmentation of this specific data set. Now I can also say, okay, these 4 points are also near, so I'm gonna combine these 4 points together. Okay, and then I can also, let's say, create another cluster which says, okay, I find these things together. So I'll put these things in one specific cluster and then create another cluster for these 2 points. So like that. Okay, so it tries to calculate the distance between these 2 points and then try to see, okay, so these are near, then we'll create a cluster here. Then from this point, it will again try to calculate the distance for this specific. And based on this distances, it decides whether it should be part of the algorithm, should be part of that cluster or not. Now k-means, what it does, it uses the actual point which is there on the plane. You can see this one, it would randomly select any point to start the algorithm, to start running the algorithm. Whereas k-medoid, what it does, it lets user or the analyst, whoever's working, define the point. You can choose any point which is in between here, which is not there, but you can create a point here, and then from that point it will start calculating the distance. Okay, so that's the difference between k-means and k-medoid. Okay, next one is hierarchical. Okay, hierarchical clustering is again where if you have certain hierarchy, if you want to, if you want your data to have certain hierarchy, for example, if you're trying to cluster between, a posh area in a city and a city with a little less posh area and, some, what you can, not slum, but something between posh and, slum. And then the last category would be slum. So you have certain categories to define in your data. Then you would use hierarchical clustering, okay, which would simply cluster based on the hierarchy. Okay, so these are the algorithms, and there's one more which is called market basket analysis. Okay, market basket analysis is generally used. You would have noticed if you had gone to any supermarket, okay, so what they try to see, if you've bought Kellogg's, okay, whatever, corn flakes, okay, what is the next product that you picked up, or what was there in your basket? Let's say you've bought a lot of products for your monthly ration, okay, so they try to identify whenever you come, what are the common products that you buy, and not only you, in overall all the customers, whoever comes, what is the probability? So they come up with different patterns like cornflakes. Okay, if a customer comes and buy cornflakes, what is the probability of him buying a milk packet? Okay, this is again, and you would not believe that you will seriously see some really nice patterns. That is something. Now this is a very intuitive one, because whoever's gonna eat cornflakes, he's also gonna need milk. Right, so this is the intuitive one, but there are some really nice correlation you can come up with while you can working on this market basket analysis. So the classic example that you will keep listening every time you will hear someone talking about market basket analysis is beer and diaper. So that's again a two very different products. Diaper is generally used by kids. And and beer is something that men generally prefer to buy, right? So whenever a person who's married and he has a child, at place, and he wants to buy a diaper, he would also go and buy beer with that. So that's the kind of relationship that Walmart had came up with last time whenever they started working on this specific analysis. And based on these things, in supermarkets, you would see that the products have been arranged like that. So if the probability of buying milk after cornflakes is really high, they'll keep milk packets right next to the cornflakes. And then after that, if you see that, okay, tea powder is something which is consumed by the customers, whoever's buying these two products, then the tea packets will be kept next to the specific product. So that's how the market basket analysis works. Okay, this is also called as, the name of the algorithm is association rules. Okay, this is the name of the algorithm, association rule, and this is the analysis is called generally. It's what, or maybe what I can do is I can put market basket in this thing. Okay, I'll just save this thing for you, and then I'll send this thing across to you. Okay, so that you can refer it whenever you want to. Let me just save this thing now for now. Document. Class 4. What happened? My Excel is acting funny. It's taking some time. Okay, now it's saving. Okay, so these things are clear, right? In machine learning, these are the algorithms that you would use. Okay, you can also write under classification, also regression, also clustering. You can write down one algorithm which is nowadays is a very hot topic, which is deep learning. Okay, So deep learning will come under all these three categories. It can be used for classification, it can be used for regression, it can also be used for clustering. If there is no pattern, it would identify a pattern and it will cluster your whatever data points based on those patterns. So a deep learning is again, so what I'm gonna do is I'm just gonna mention it here for now. Here, which is because I've already entered neural net here, which is not very different than deep learning. Deep learning is basically having multiple layer of neural nets. So I'm just mentioning it here for now. Okay, so let's jump into the core topic of the day, which is regression. Okay, so let's first of all see what do we have in the data. Let me see what data I'm going to use. I myself did not know what data it is. So, so where is it? And credit card data. Okay, so what we're going to do is we're going to use credit card data. Okay, so have you used this command before? RM list is equal to ls, open close bracket.
No, what is that?
Okay, so this really helps you clearing all these things. Let's say you had worked on a project. Now you don't need that, all these data points, you don't need it. Now you're going to start a new project and you want this board to be blank, this global environment to be blank, so that whatever you import should be visible over here rather than the older ones, because these are all the older ones that we worked last time, right? So I want to erase these things. So I can use this specific command which says remove, RM stands for remove, list is equal to ls. Okay. If I print only ls, you would see all these names coming up here. Okay, even including the ones within, under this value section, you'll see all of these. Now, so I say create a list of this and then remove them. Okay, so let me just run it. There you see, everything's gone. Now it's blank. So we can now start working on our model, and whatever we do will be visible here. If we import the data, we create a new data set, everything will be here. So let's go ahead and import this data set, which is, okay, so I'm setting a working directory. So I'm going to use this folder for all my work. Okay, so everything I have will be stored over here. Now let's start setting, start with the project. So I've set my working directory. Now I'm going to use, in this working directory, I have this credit card data set. So what I'm going to use, I'm just going to use read.csv and, say header is equal to true, which means the first line of my data should be my header, should be the header of the data. And I'm going to give that, that data a name. Okay. Or maybe I can give any other name. No, let's keep it, because then I'll have to change the entire code then. Okay. Okay. So let's import the data. Well, there it is. So just to see what the data has, okay, let's go through first few records. So let's see, what do we have. So we have loan, which is either bad or good. So bad loans have been tagged as 1, I'm sure, and others are just kept as 0. We have balance of the customers, duration of the credit, month, payments, payment status, etc. So this is nothing but customers information, some bank or account related information, some demographic details as well. What is the gender of that person? What is the marital status? Did he have guarantors, etc. So some demographic details, some bank product related details, and based on that, they have tagged all those customers, based on their performance, whether they've defaulted or not. Okay, so this is the credit card data. So have they defaulted on their credit cards payments or not? So we have age as well, concurrent credits, type of apartment, etc. Anyways, so number of dependents also. This plays a really huge role. If you have number of dependents, this specific variable plays a huge role generally, because I've worked on some of the banking projects. So yes, I can say that. Okay, then let's see the structure of the data. Most of them are integer. Okay, but I'm sure there are some of the variables which are categorical, and we will have to convert them into factors before proceeding further. Okay, And to give you an example, now this guarantors, okay, guarantors may not be more than 3 or 4. So having them as integer rather than having them as integer, we'll have to convert the specific variable into factors. Okay. Now let's see what we are doing next. Okay, yeah, whatever I was saying, that's actually what's going to happen next, which is we are converting variables to categorical variables. Some of the variables, not all of them. Okay, the categorical variables are converted to factor variables, and then it's used directly to in the model. Okay, and R comes up with a unique feature where you don't really have to convert your factor variables and create and go ahead and do the coding, dummy coding basically. Dummy coding works like this. So if you have factor, let's say Mumbai, Delhi, Chennai, and this is my whatever, Chennai again repeated, Delhi again repeated, and then Bangalore. Now, Mumbai will be categorized as 1, and this will again, okay, let me just do it as R does. It arranges, it gives number based on alphabetical order. So it will give Bangalore 1, Chennai 2, again 2 because it's repeated. Delhi would be 3, and then 4 Mumbai. Okay. Now, this is what the data will look like. The actual data will be like this, where you'll have actual city name. All you have to do in R is convert them into factors, and this can be done using this specific command as dot factors. Okay. And then once you do that, you can simply use this specific column, which is converted using this to this, okay, in your model. Whereas if you're using Python, then in Python, what you'll have to do is you'll have to create dummy coding. So when I say dummy coding, okay, so it's also called as one-hot encoding, or and encoding also. It's no. So what you'll have to do, you'll create one Bangalore, Chennai. Let me go back to, okay. Let me shift to the next tab. Actually, there's a bit of, I'll have to otherwise keep adjusting the column names. Okay, then Chennai, Delhi, and Mumbai. Okay. Now, so under Bangalore, whenever Bangalore occurs, you'll have 1, and then in all the other columns you'll have 0. Now, in Chennai, there are Chennai is appearing here and here, so it will be 1. Otherwise, everything will be 0, 0, 0. So this is what dummy coding is known as. Okay. So in R, we generally take this thing and we don't really worry about dummy coding, one-hot encoding. Okay. So we just convert this into factor, and that's what we're going to do next in our data. I'm switching my screen to R again, and let's run this thing. So we are converting, purpose of the, so this is the purpose column. I just need to check what was the purpose. They've given some numbers. Okay, let it be. So let's convert this into factor. Okay, then the next is sex, marital status. Again, type of apartment. So all these things are, categorical variables, and we need to convert them into factor before we go ahead and run the model. Okay, so I've run everything. Now I'm going to change the structure of the, the data set once again, and there you would see the ones that we had converted are showing up as factor now. Okay. Okay. Now let's go and define a function. So this is a function that I'm written in R, and are you aware of what functions do generally in R?
No.
Okay, so if you have any repetitive task, to perform, so what you can do is you can write a function, and you can use those functions whenever you want to perform that task, in any of your analysis. So this specific function I've written, I can use this function in any other model wherever I need to run a descriptive statistics. Okay, so this does nothing but it runs descriptive stats. It runs and gives me an output as a descriptive statistics of the data. So what I do in function, so I am
Asu, is it possible to increase the font size?
Okay, it's not visible.
I don't know if I have to see. Snehan, is it okay for you?
Yeah, I can see.
I'll increase it. No issues.
See, if it is.
Let me see. If I increase it a lot, then is it better, Krishna? Just let me know.
Yeah, now it is okay.
Now it is okay, right?
Yeah.
Okay. Now I'll have to maximize this part otherwise, because otherwise the entire code will not be visible. I'll keep this part a bit. Let me, yeah, I'll just move this a little down. Okay. So what this function do now? You can see I've named this function as, variant summary. Okay, variable summary basically, and then I've created a function, and I'm just mentioned this x, and this is nothing but a placeholder for my data. Okay, so what I'll do next time I write this function, I'll write this name, and within bracket I'll give this input, which will be my data set. So this is something that I'm going to do next. Okay, and I'm going to show you what it is. So this function, generally what it will do, will pass our data through this function. Okay, and what it will do, it will simply check. Okay, first one is numeric. It will check, okay, the variable that I've given here as x, is it numeric? Then based on that, it will say, if it is numeric, then it will simply calculate the length of the x, which means how many elements are there in that specific variable. Okay, nmis generally identifying, is there NAs in the data. Okay, so it simply takes the sum of true values or true or false, whatever. This generally gives you either true or false. Okay, and sum simply counts the values of true. How many times true has occurred, it will simply count that sum. Mean generally takes the average of that variable. Standard deviation, again SD, which is, I'm checking the standard deviation of the variable, and then I'm checking the variance. Okay, so variance is generally not used, but still, since we are doing descriptive statistics, it's good to have all the stats in one specific page. Okay, and that's the reason I've included it. Then I'm checking minimum, which is again used for calculating range, minimum of that x variable. Okay, and then I'll calculate quantiles, my percentiles basically. My first percentile is my, first 1 percentile, and then 5th percentile, then my 10th percentile. Okay, so this will simply tell me, okay, how many data points do we have in our first 10% of the data? What are the values that we have in the first percent of the data? Then I'll calculate my quantile one, which is 25th percentile. Then this is mean, which is 50th percentile. Sorry, this is median, which is 50th percentile, the one that we had discussed in the last class. This is my 75th percentile, and then 90th, 95, and 99th. Okay, and then I have maximum, which is the maximum value again against minimum. Okay, I would like to see the maximum value as well. And then this ULC, this is called as uppercut and lower cut. Okay, so UC is uppercut, which simply tells me that plus standard deviation, what should be it. So what I'm doing, if you remember in the first class, I had said, maybe I had to close that. No, I had said, right, this specific part, 1 standard deviation, 2 standard deviation, and 3 standard deviation.
Yeah.
And whatever after that is outliers basically. So we can simply go ahead and cap them, right? So what I'm doing here, from the mean, so here you would see, from the mean, I'm calculating plus 3 standard deviation. Okay, there you would see. So what it will do, it will calculate this specific part. Okay, plus 3, and I'm also taking from the mean negative 3 standard deviation. Okay, so I'm calculating my negative part as well, and anything apart from this specific, in this specific region, apart from ahead of 3 standard deviation, will be considered as outliers. Okay, and that those we gonna cap simply. So this function, again, this specific line of code will give you the upper limit. Okay, and there's another technique you can also do that. You can otherwise, if you're interested in simply capping anything which is above your 99 percentile, this is also a very frequently used technique. Instead of going with the standard deviation, if you feel better about using capping anything which is above your 99 percentile, you can also do that, and that's what this specific thing would do. Okay, and this is again the lower cut, and that's the second one, and this has below 0.01, which is my 1%. Anything below my 1% will be simply capped, or we will cap it. So this specific line will give me how many values do I have below my 1% or whatever 1 percentile. This is called as interquartile range. So IQR is nothing but interquartile range, which is nothing but the difference between your third and your first quantile. Okay, so it's simply going to. So there is a function, you don't have to worry, or you don't have to calculate. It simply gives you the difference between your third and the first quantile. So next one is, okay, there's another interquartile range. So I'm not going to explain this one. You will get confused. Okay, so just remember these two things, because these are the ones that are used very frequently to look for outliers. Anything beyond plus or minus 3 standard deviation can be considered as outlier, and anything beyond 99 percentile or less than 1 percentile will be considered or can be considered as outlier. Okay. This is, I'm doing nothing, I'm just using the third here just to explain you. I'm using this interquartile range, whatever I've calculated. I'm trying to see, okay, my Q3, okay, is there anything greater than 1.5 into my interquartile range? So this gets a bit mathy, so I don't want you to get confused here. So, and this is not very frequently used also. This is just while working on certain project, I just wanted to explore all the stats, and that's the reason I included this thing in my codes. Okay, now this is again what I'm doing. I'm trying to calculate the max, okay, which is nothing but the value that I'm gonna get here, min and max, okay, and this is going to give me a true or false value. What I'm saying is my max greater than my UC1, which is nothing but this one, the range that I've calculated, okay, or is my minimum less than this? If yes, then it will be true. This value will show as true. This specific bar is nothing but stands for OR. Okay, you can consider that as OR. Okay, if you had both these conditions to satisfy at once, then you would have used this specific sign, which is AND. Okay, so we are right now looking for any value, any of these values being true. Okay, and that's the reason I'm going with OR. Okay, so let's do that now. So this is the function. This is where the function basically ends, this part. Okay, where I'm just gonna calculate all these things. Okay, and I'm gonna put these things in a specific table format. Okay, and I'll call that table as free. Okay, and then I'll use prop.table to check basically the properties, the percentages and stuff. So this is nothing. There's nothing. I'm not doing anything. Okay, I'm just putting this in a tabular format. Now let's go and create the variables that we would like to pass through this. Now, in order to calculate all these statistics, you can't really use factor variables. The one which are categorical variables. You must use numeric variable, otherwise you're gonna get different or wrong result. Okay, and to do that, you have to differentiate. You have to create groups of your numeric variable as well as your categorical variable. Okay, so here I'm simply creating a group of, I've taken the name of all the variables which are numeric and the ones which are categorical, and I've named them as numeric. Let me first run this specific function. So this is just a function. So when I run this, you will not be able to see any output. So there's no output. Okay, I've just created a function. Now this specific part I'll pass my variables one by one in this function, and it will give me all these stats relevant to that specific variable. Okay, and to pass all the numeric variables through this, I need to segregate between my numeric and my factor variables. As of now, all my variables, the specific data set that I have, it has a mixture of both numeric as well as factor. So I need to differentiate or keep these things to aside. Okay, and for that I'll create so let me first know the column names. So these are the column names. Now by just looking at it, I know, looking at them, I know which ones are numeric and which ones are categorical. Okay, then I'll also, just to make sure that, okay, just see, okay, I'm not selecting anything wrong. Let me just put this thing a little down. Okay, so I'll just make sure whatever names I've put here, they all are correct, they all are numeric itself, and I'll go ahead and I'll create this specific vector. This is called a vector. Okay, So this is my numeric vector. Let me print this. So when I print this, I'm going to see all these names of the columns. Similarly, I'm going to run for categorical variables as well. Now I have my numeric as well as my categorical variables separated. Okay, so this has not really separated within the data. I've just put their names in two different vectors. Now, whenever I would want to select only numeric variable from this specific data set that I've imported, which has 1000 observations and 21 variables, it will only select, okay, and I'll have to pass this name basically. It will only select these variables only. If I want to select only categorical variables, then I'll give this specific name, cat underscore variable, and it will only select these columns, okay. Applying functions on the numeric data. Now, whatever function that I had created, I'm going to apply that. So if you remember, the name of the function was var underscore sum. Okay. So here I'm creating a table basically. This is the name of the table that I'm going to create. I'm creating a data frame. Okay. Within that, I want it to look transformed. So this t function is nothing but, it's going to not transform, sorry, transpose. Okay. It's gonna, what transpose is, Snehan?
No.
No, right? Okay. So just to explain you how a transpose would look like. Okay, so you see this table, consider this as a table, okay? We have this table in this specific format, right? Now, if I transpose this, it would look a bit different. Let me show you how we can do that. So in Excel, there is a option called paste special where you can just go, okay? And you can use this specific last option, which is called transpose. And you click OK. Now, do you see the difference? If you don't, I can explain that. I mean, it's fairly easy.
The rows are columns and the columns are rows now.
Exactly. So these rows, these columns have become rows, which are here, and these rows have become columns, and the values have already been assigned accordingly. So it has not changed the value of the table. It's just tweaked it, based on the format that I require. Okay. So transpose does this, and that's the thing that this T is doing here. It's creating a data frame. Within that, it's transforming the value according to a readability, to bring it in a readability format. Now, apply function basically whenever you have any specific calculation to apply or a function to apply on a range of or on specific set of columns within your table, you can simply use this use this apply function. Okay, so now what I'm going to do, I'm going to apply this specific function, which is variable underscore summary. Okay, and I'm going to apply them on this specific set of variable. Now if you remember, this is my data. Okay, this is the entire data name. Now I want to select only numeric variable. This is what I've created. These are all my numeric variable. So I'm giving this specific. So now let me just print this thing out. If I print this, okay, this will give me all the data. This will print all the data. Okay. So I want to select only numeric variable. Okay. So within square bracket, I've put these things. Okay. So within square bracket. Okay. Now why I am using OneDrive, I don't know. Okay. So within square bracket, there are two arguments you have to pass. One is the number of rows or the name of the rows. Two, number of columns, which specific column, the index of columns or name of the column. So name of the columns have already been written here. This one, this, if I print this thing, these are nothing but the name of the columns. So what I'm doing here, I'm selecting all the rows, which is kept blank. So I'm selecting all the rows and I'm selecting these columns only from the specific table. Okay. And this argument defines whether you want to apply this specific function, which is named here, which is kept here, on your row or column. Okay, so when I say row, let's assume if you want to add 2 or multiply all these elements with 2. Okay, so you will have to write a function which will, what it will do, it will take this, okay, multiply with 2, and then or maybe you can just maybe do it here. It will take this column Bangalore and it will multiply it with 2, and so on. It will keep doing that until it reaches the last number. Okay. Now, this specific function was applied on this specific column. Okay. Now, if I only wanted to do this operation for, let's say, a specific row, which is this one, okay, then I would have used one here, one, right? Now I'm doing this for column, and that's the reason I've kept 2 here, okay? And then I've defined the function that I've created. Now let's run this one. Now I've run it, okay? Now let's view this thing, whatever we've created, let's view it, or there you go. So these are all numeric variables names, okay? With number of, how many numbers do we have, what is the length, how many elements do we have in each variable. Then nmis generally tells me how many NAs are there. So there are no NAs, you don't have to worry, okay? Then you have means, which is average, standard deviation, variance, everything that you would want to see is there. Whatever we have mentioned over there, all the percentile values, min, max, my upper limit, lower limit, everything is there, okay? So everything. So this based on this, you can simply read, what is the dispersion of my age, what is the maximum, okay, minimum I have 19. So I've given a credit card to a person who was 19 years of age, 19 years old, okay, giving a credit card to a person who's below that, it's a risk only, right? You don't want to give that. And maximum 75 is the age. So similarly, you can see the dispersion of your data pretty well here. Let's take another example, duration of credit limit or credit amount. So there you would see my credit amount minimum is 250 and maximum 18,000 is what I'm expecting someone to pay. My 75th percentile is 3,772, so 972. So this is how you can just check the distribution of the data, okay? And you can also see whether there are outliers. Okay, so this outlier flag says 1, which means there is outlier, okay, in these specific columns. Based on the outlier cap that we had selected here, these are the specific variables which have outliers, okay, and that's what we're going to treat in the next upcoming code. Let me go back and open linear regression. Okay. Now treating the missing values basically. Okay, so if there are many values, missing values, let's say if 25 to 30% of the values are missing from a variable, okay, it would be better to drop that variable rather than trying to impute a missing value, because if you, first of all, the values are missing. Even if you're using mean, average, mean, median, or anything mode to fill those missing values, you're not 100% sure at the end of the day whether that's the value that you would want to do, right? So whenever the missing values are like somewhere between less than 20%, then you can go ahead and use any of the missing value treatments, where you can use mean, you can use median, you can also use mode if that is a categorical variable, okay? And that's how you can, or if you are very much expert in your business and okay, mean is not going to help in that case, so you can, based on your business knowledge, you can try to come up with some numbers that would make sense, okay? And in extreme cases, if you're not 100% sure, and even if you don't want to drop that algorithm and you're not sure whether to use mean or median, then you can use KNN algorithm, the one that I mentioned, K nearest neighbor. What it does, it uses other X variables, independent variables, and it tries to match, come up with the nearest value that missing value should have. Right, and it'll simply go on and impute all those missing cells with the nearest best match. Okay, so that's again extreme case I'm saying. Okay, so here I've mentioned either you replace missing values with average or median, or use KNN to fill the average value. Okay, now let's use again the apply function, and then what I'm gonna do, I'm going to use, mean to impute my missing values for column numeric variables. For all my numeric variables, now I am a business person. I know that I can simply impute my missing values with mean. So I can go ahead and use this specific code where I'm imputing all my numeric variables, which I mentioned here. Okay, all the columns, which is 2, and I'm replacing them with my mean. okay, mean of that specific variable. So let me run that. That's done. Again, for categorical variable, if that I'm missing, then I'm going to use mode. Mode is nothing but whatever that occurs, which value that occurs maximum time can be used, right? So I'm simply doing which max, which is which specific fact or category which is being repeated maximum time can be used to replace the missing values. So I'm again gonna run this code. Okay, handling outliers in numeric variables again. Okay, now capping and flooring. This is called capping and flooring. Okay, whenever you're trying to cap your outliers, which are extreme value basically. Okay, so first before doing that, we need to plot it, right? Let's plot that. Okay, so here you see that what I've done, I've plotted this credit amount thing to find out whether what is my are there any outliers, but it's a bit difficult to understand using this one. But what you can do is you can use the 99 percentile, and anything above that, you just going to cap that to 99 percentile. So anything which is above, so let me insert line, which is, let's say, this one. Okay. Now let's assume. Let me just minimize these column lines. Otherwise, it will be a bit difficult to explain. Okay. Now let's assume this is the cutoff of my 99 percentile, and this is the cutoff of my. Okay. Back. And then this. So this is my less than 1 percentile, okay, or I should write less than 1, and then greater than 99. So whatever values I have, these things, I'm just going to cap. Let's assume that I have 16,000 at 99 value, 16,000 in 99 percentile. Okay, then I'm going to cap all the values which are here, which are extreme, to 16,000. So I won't have any extreme values from this end, and from this end as well. Whatever less than 1% will be capped to my whatever value I have at first percentile. Okay, let's assume we have somewhere around 200 here. So I'm going to cap all the extreme, the lowest values to 200 here. Okay, that's what I'm going to do here also. So what I'm saying in credit amount, whenever the credit amount is greater than this thing, then use quantile. Okay, and then quantile of the credit amount itself and the 99 percentile. Okay, and then impute it. So what I'm doing, I'm selecting only those cells which are greater than 16,000. Let me print this. So there is only one value which is greater than 16,000. Okay, and you would see that this is that value. You see it, 18,000. Yeah. So I want to cap it now. Let me do that again here. Well, it's done. Now if I believe if I plot it, now you're not able to see it, right? I've replotted the variable. Now you're not able to see it. It's less than 16,000, whatever values I have. Same. Now let's check the the histogram as well, which gives me, there you see. So this is the histogram. Now I want to see whether it is normally distributed. Now with this, you can simply say that the data is, yes, it is normally distributed. Okay, it looks normal. But now in order to confirm this thing, you have to take, this is what you're asking, right? How would you convert a data and make it normal distributed? So that's where you take natural log of that specific variable. I'm using credit amount. I'm gonna use this specific log function, which is nothing but my natural log, and I'm gonna run this. And now you see, you can see it is normally distributed, right? More or less, it's almost normally distributed. Okay. Then what I'm gonna do, since it is normally distributed, the log normal distribution, then I'm gonna convert this thing, my actual dependent variable, which is my response variable, to log normal, so that I can do the predictions very easily. Okay, now I'm using car data again. So this is for correlation, identifying the correlations, the multicollinearity within your X variable. So let me run this again. I'm just calling this function car. I'm not running this one. I think this is not good for this data set. It works really well for other data sets, but still, just to show you what it does, it plots distribution and is it normally distributed or not, and what are the log normal distribution would look like, etc. And what is a correlation it should plot, but I'm not able to really find which plot is the correlation one here because it's very haywire. I mean, I can't really read this one. And generally, this specific graph, it shows three colors: blue, green, and red. Okay, which really helps you understanding the correlation of between different variables. But let's not get into this one because this is really not a good way to visualize this data. Okay, so I know which variables I need to work on, and that is the credit amount, which is my dependent variable, which is one of the independent variables. So let me plot this one just to show you. Okay, there you see. So this is the distribution, how the probability density looks like for credit amount. And there's another variable that I created. This is ln is nothing but natural log. Okay. The log distribution. This is how my previous variable was looking like, and this is how it looks like now. Okay, this is which is normally distributed. Okay, then let's go and plot some correlation here. Now, if you wanted to, you asking me how would you check multicollinearity exists in your data, right? So this is the function that you would use. And the other day I was trying to tell you, the core plot. There's something that you can use. This function you can use. This comes in this specific package car, and that's the reason I was not able to run this specific function. But here it should. This comes with core plot. This specific package, and let me call this one, and then now if I run I'll be able to see the numbers. Okay, so there you see it comes with color also, so it lets you say, okay, there is a little bit correlation between this specific variable, this and these two variables, this one and this one. So it 0.63, which is a bit closer to positive one side, right? And this is again the same thing. There's no collinearity actually, otherwise you would have seen numbers in dark blue color, the one that you see here, 1 1 1, which is the same variable, and that's the reason it's showing 1 and dark blue. So you would have simply seen these variables in dark blue color, and that's how you can simply understand, okay, these two variables are actually correlated and whether multicollinearity exists in your data or not. So this is one way of checking. Then what you will do now, you will simply create a training sample. What do? We divide data in two different sections, train and test. Okay, so for training we are taking 70% of the data, and here what I'm doing, I'm selecting 70% of what my 70% of rows from my data set. Okay, and I need to do this in a random way. I can't simply go ahead and select the top 70%, because what if somebody has sorted that data, right? So I would say only specific set of values. So I need to be very, very sure that I'm selecting random samples from the data, random samples of those 70%. Okay, and to do that, so this function simply selects which random or whatever. Wait, just a minute. This sample size would tell you what's the amount of. I think we have 1,000 observations, so 70% would be what? 700, right? Yeah. And that's how it should be. So there you go. That's 700. So we've made sure that, okay, whatever random sample that we're going to pick will be 700. Okay. Here, and that's what we are going to use. The 700 we are going to use here when we are selecting the samples. Okay, from that same data set, 1,000 observations, and we're going to use 700 as our train. So this is where, and set.seed is basically used, and this number is basically, you have to remember this number, that's it. Set.seed is generally used to so that you can reproduce this sample once again. So what happens is, whenever you run this sample thing, it would automatically select different combinations of rows. So to prevent that thing happening, you have to use set.seed. So next time, after running this thing, so next time whenever you try to okay, this is really irritating. Uh, so whenever you try to run this, again select the sample set of sample and not some random ones. Okay, let's go ahead and do it. Let me just do it again. Okay, it's done. Now I'm going to create my training data set. Okay, and for training data set, what I'm saying, this is nothing but this has selected the random index of my rows, number of rows, which specific row I'm going to select. Let me print this one. So if you see, this says my 159th row will be selected, 327. So these are random sample numbers, row numbers. Okay, and those numbers I want. So I'm creating my training data, which says, okay, select all the rows and all the columns, which is blank here, and that's the reason it means all the columns. And for test, what I'm doing, I'm putting a negative sign here. So anything which is not this thing, these thing should go into my test data set, and my training and test data is ready. Now let's go ahead and run the model. In order to run the model, you have to use this specific function, LM. LM stands for linear model, and which is an inbuilt function in R. You don't really have to call it or install it separately. Okay, so linear model is already inbuilt function in R. So what I'm going to do in linear model, I'm going to put my this specific variable, which is my response variable, and with the plus sign, I'm going to add all the independent variables right next to it. Okay, and once I'm done, with next to a comma sign, I'm going to enter my data name, so that the algorithm should know, okay, from this data set, I need to pick all these variables, and then need to fit a linear model, which will be done by this specific function. Let's run this. Okay, the model has been run. Now let's go ahead and check the model, summary of the model. How can you read that? Okay, let me just put this a bit up. All right. Here, what you could see is these are residuals. Residuals are nothing but the error terms. Okay, and what is the distribution of your error terms? What is the minimum and the maximum value, and what is the median of my error terms? So it's not too much, because it's lies between -1 to +1, and all your numbers fall in between these two things. So which is a good sign. If it is really it started from -1, it goes up to 1,000, then there is a problem. Okay, so error terms are not very widespread, so you don't have to worry. Now in this specific thing, okay, you must read this specific value. Okay, this is nothing but the error, how far apart these variables are. So you don't really have to worry about this one. Nobody's going to ask, or you won't be using this specific information anywhere. Okay, this estimate is nothing but the intercept value. Okay, so this will again be remain same. It won't change. And then yeah, so you have to read this thing, which is nothing but my p-value. Okay, so when I say p-value, it should be less than 0.05%. Okay, not percent, sorry, it's 0.05 number, which is like 5%. So this one is less, right? So you would see that intercept is this one, and then these are the coefficients, and this has 3 star right next to it, which means it is a significant contribution. This contributes well for this model, so you can't really make any change in the intercept. So let's keep the intercept as it is, which is not a variable, which is something that model has derived itself. So we are not gonna check that. We are not gonna change that. Even 1 star says that, okay, this variable is significant. You can also see that this value is less than 0.05, and that's the reason you have a star mark here. And more the star mark, better the the variation explanation capability of that variable. Here you don't see anything, which means this is not a very good predictor. Which is account balance has 3 different categories. So category 2 and 4 are better. It can be used, but category 3 has no explanation power. Similarly, you can just go down and you see, okay, which specific variables are significant. Okay, and then next time, in the next iteration, you can use only those variables, and you can simply go ahead and drop these ones. Okay, so this is how you can select the significant variables. Okay, but there's another way to do that, which is an automated way, which I'm going to show you next after this line of code. Okay, but before that, again, reading. So whenever to make sure how accurate your model is, you should always always check the adjusted R score and not just the R square, adjusted R squared and not just normal R squared. Okay, adjusted R squared generally, so difference between the two is R squared, whenever you add any new variable, R squared value increases, right?
Increases.
Exactly. Adjusted R square, what it does, it penalizes based on the predictive power of that variable. So if that variable that you've added recently, if it is not really doing any better to the model, it will reduce the adjusted R square score. So you'll get to know, okay, in the first iteration, I did not have this variable, so my adjusted R squared value was high. But now since I've added this variable, it has gone down. So I need to remove that one, right? So for that reason, you'll use adjusted R squared. Now, also the overall p-value score, which simply tells you how well the model has been fit. So should be or must be less than 0.05, which is in our case, yes, that's the case. But still, rather than selecting these variables manually, can you do it, like in an automated way? So for that, you have to use this specific package called mass. Okay, in mass, there is a function called stepwise function. Stepwise function, basically, there are two ways to run a stepwise function. One, it's forward elimination, forward selection, or backward elimination. So what it does in forward thing, let's say we have 10 different variables. It selects one, okay, and then build a model, check the AIC value, which is archaic information criterion. It's don't worry about the jargon, just remember AIC. Okay, later on you will remember what it means, archaic information criterion. So basically this number tells me how good my model is. So higher the number, better the model. Okay, so it checks the AIC, then it adds another variable and see the AIC value. If AIC has increased, then it will keep this thing, otherwise it will drop again. Okay, it will simply remove this one and then it will check the next one. It will add this one and then it will again check the AIC. If it's good, then it will keep it, otherwise. So this is forward selection. Backward elimination, what it does, it selects all the variables. Let's say we have all these three variables. It runs the model, it checks the AIC value, and then it see, okay, this one has a lower probability, the p-value, I'll remove this one. And then it again calculates the AIC. And it will keep calculating the AIC until and unless it gets the highest score, okay, highest possible score. And that's what we're going to do here in the next step. Okay, so step AIC is nothing but the stepwise method, and AIC is the criteria that we use to check whether the model is good or not. So I'm going to use this model. So I name my model as fit. So I'm going to use this, and then direction, I've set both. I can say forward or I can say backward, but I've set both. So what it will do, it will first check forward. Okay, it will try run all the models from the forward method, and then it will use all the run all the models using the backward method, and then it will give me the best one. Okay, so let's run this thing. Fit2, let me do this thing. So here you would see, let me just maximize this window, how many models it has created. This is 1, this is 2, this is 3, 4, 5, 6, 7, 8, okay, 8. That's created 8 model. In every iteration, now starting with the first one, and at every iteration you can see the AIC value 1057. Okay, it will keep improving. Now AIC value has gone up to, okay, 1057, 259, okay, 61, then 62, then 64, 65, 66, okay. And that's how you will, okay, and this, I think below one is not showing completely. Okay, let me just come back to this one. Okay, so now since this has the highest AIC value, I would consider that this is my best model, which is my fit2. Okay, fit2 is, I've not run it, okay. Yeah, fit2 is not run, okay, step 3 is what I did, right? Okay, so the one with the highest AIC value is my model. So based on that, I'll get to know which variable is the one which has the maximum, capability of explaining your variation in your response variable. So I'll take only those variables which my stepwise method has suggested me. I'll only take that manually. I'll select that manually and I'll run my final model, which is fit2. Okay. And I'll check the summary of my fit2. Okay. And which tells me, okay, my adjusted R square has gone up a little bit, not much, but it has gone up. Yes. And my p-value is again less than 0.05. So this is the best I could produce using different techniques that I know of. So there are different ways where using which you can actually improve the score of this model as well. Okay, but I don't really want you to bombard with everything and then you go confused. So this is the best technique, best method that you could use to build a linear regression, also a logistic regression. The same format we will follow for other algorithms as well. Okay. And I've included one more thing just for information, which is, so we are done. We've built a model. We've checked the accuracy, which has gone up, the adjusted R square. Okay. But just for your information, because you had asked for about VIF, right? Variance inflation factor. So this is along with the correlation, the core plot we have generated, we can use VIF as well. Okay. And VIF, if your score of VIF is greater than 2, then the correlation, the multicollinearity thing exists in your data. Okay. And VIF, the formula of VIF is nothing but 1 divided by 1 and then R squared. This is it's not R2, it's R squared. Okay. And that's how your VIF is calculated. So I just included this for your this thing. Maybe we can just, let me see if I can run this thing. There you see. So it's all below 1, right? It's all below 2. Can you see it? The VIF score here, right? It's all below 2. So there is no multicollinearity, and these are all your variables that you've used for prediction. So there is no collinearity. So you can just build a model without any doubt in your mind. Okay. So this is how you can use VIF. So I think that's all from my side from now. I would request you to go through this model once again. I'm going to send you the code after this call. Okay, so whenever you get time, just go through it, and then if you have any question, we can take that up in the next class. Or if you have any questions right now, you can ask me. We can try to answer it now, or if you remember something next, before the next class, you can ask me there then in that class also.
If I find multicollinearity, then I have to remove that specific variable, right?
Yes. So what would you do? First thing, the multicollinearity, let's assume multicollinearity exists. Okay. So the first thing you would do, you'll try to check, you'll take those two variables which are correlated. You'll check their correlation with the response variable. Okay. And if, let's say, let me show that in Excel, that'll be again. So I have a variable A and variable B. Okay. And these two are correlated, right? And I have my response variable Y. So when I know these two are correlated, what I will do, I'll check correlation of A and Y, which is, A with my response variable. And I'll also check correlation with B and Y. And let's say B and Y, these things, these variables are highly correlated. Then I'm going to keep this one and I'm going to drop this. Okay. The one which is not correlated with my, which means it doesn't have, capability, much of an impact on your model. It will not have much of an impact. So you'll simply go ahead and remove that. Okay. So you'll keep the one which is highly correlated with your dependent variable.
Okay.
Okay. Cool then. So if you have any question, we can take that up in the next class.
Okay.
Okay. Cool. Thank you, guys. Krishna, you have anything to share?
No, sir. Nothing.
Okay, perfect then. Okay. Thank you, guys. Have a nice good night. Then see you next tomorrow, or I'll confirm that time. Okay.
Okay.
All right. Okay. See you
Good night.
guys. Good night, guys. Good night.